Workout 1 for lesson 28. For this one, we have a rod, and we are basically deriving the equation for the moment of inertia for a rod rotating about its end. So we know the rod is mass M, and it has a length L, and we need to start from our general form of the equation. So I equals the integral r squared dm. However, we know in our example here we have a length L of this rod, and its mass is M. So we know we're going to integrate from 0 to L. We want to integrate along the length. So that means that we need to change dm into dl, and some change in length there. So we know that the mass per unit length gives us basically how much mass is on some small section of length of this rod. So that goes to dm over dl, would be the equivalent, right? Some small change in mass over some small length over that total thing is going to give us total mass over total length. So that means that dm is equal to m over L dl. Now we can substitute that back in. So I, for our case, is going to be the integral from 0 to L, because we're integrating along the length, and R is just how far out or how far along the length we are, L squared, and then dm, we found dm over here, so that's m over L dl. So if we proceed through and integrate, we pull our constants out, 0 to L, L squared dl. This gives us m over L times 1/3 L cubed evaluated from 0 to L. And when we plug all that in, we get 1/3 L cubed minus 0. Those L's are going to cancel, and what we wind up with is 1/3 m L squared, which is what's on the equation sheet.